Hello and good morning. Today we're going to do 4.4 decimals and fractions. We are going to have a quiz coming up sometime soon. What operation does the fraction bar represent? Well, if you don't remember, fraction bar represents the same thing as division. You can take the top number, the numerator, and divide it by the denominator. And that's exactly how we change fractions into decimals. I call it neato. You divide the numerator by the denominator, and the numerator goes inside the house, numerator in, denominator out, and you end up getting your decimal equivalent. So let's write each fraction or mixed number as a decimal. Some of them you might know by heart, and that's okay, like 1/4. You might know that it's 0.25, but I'm still going to divide it. So I'm going to put the 1 inside the house, the numerator on the inside, the 4 on the outside. I'm going to put my decimal point and bring it up. Annex to 0. 4 goes into 10 2 times. You get 8. Subtract. You get 2. Annex another 0. Bring it down. And 4 goes into 20 5 times. And we're done. I'm running out of room. Okay, so 1/4 is the same as 0.25 or 25/100ths. If you want to, you can pause the video and try these yourself and then check afterwards. That works as well. So 5 goes inside the house, 8 goes on the outside. I need to put my decimal point, bring it up, annex to 0. 8 goes into 50, 6 times, 48. We get 2. Annex to 0, bring it down. 8 goes into 20, 2 times, and we get 16. Subtract, we get 4. I'm running out of room again. 8 goes into 40, 5 times, and it's going to be 40, and then equals 0. I do not have room, unfortunately. So 5/8 is the same as 0.625 or 625 thousandths. 3 2/5. Okay. The 3 is just our whole number. You don't have to worry about that. Just remember to place it in your answer. The 3 will go on the left side of the decimal, and any whole number that you have will just be placed there. 2/5, we have to change that. Neato, numerator in, denominator out. Decimal, bring it up, annex to 0. 5 goes into 20 4 times. That was easy. Okay. So 2/5 is the same as 0.4, so we just place that decimal right to the right. And 3 2/5 is the same as 3.4. Another way you could have seen that is 2/5 you can change it to 4/10, and that's 4/10, which is the same as 0.4. So sometimes you're going to be able to see them, and that's okay. Okay, terminating decimals are decimals with finite number of decimal places. That means that it ends. But what about those fractions that don't end, which are like these? 2 goes inside the house, 3 goes on the outside. Decimal, bring it up. Okay, 3 goes into 20 6 times, and we get 18. Subtract, we get 2. Bring out another 0, and right away you could see what's going to happen. It's going to be another 6, and then another one, and another one. So we can automatically put bar notation. Okay, 1 is going to simply just go in a whole number.
Good morning, can the following?
Okay, sorry. Announcements were going. I wanted to stop. So 2 goes inside the house and 9 goes on the outside. We got to get our decimals and annex to 0. 9 goes into 20 2 times, and we get 18. Subtract, you get another 2. Annex to 0, and you can already see what's going to happen. It's going to keep being 2 2 2. So we could put the bar notation and place it there. Now there's also a trick. Anytime you have a fraction over 9, it's going to be repeating. So 1/9 is going to be 0.1 with bar notation. 2/9 is going to be 0.2 with bar notation. 3/9 is going to be 0.3 with bar notation. 4/9 is going to be 0.4 with bar notation, and so on. So if you look at 2/3, 2/3 is equivalent to 6/9. And that's why it's 0.6 with the bar notation. It's repeating. Now, if I also wanted to do 44/99, that is also going to be 0.4 repeating. And the reason is because it simplifies to that 4/9. Okay, so repeating decimals are decimals whose digits repeat forever, and we use bar notation to tell that a decimal's digit repeat forever. And we learned this. You guys know this. Okay, take a look at this decimal. You can pause the video. I want you to think about if this pattern continues, is this a repeating decimal? Why or why not? And then you can play it. I'm going to tell you the response. Okay, so that if the pattern continued, it is not a repeating decimal. It was 1, 2, then 1, 1, 2, 2, 1, 1, 1, 2, 2, 2. There is no pattern here for us to put bar notation. So no, it is not a repeating decimal. And common fractions and decimals that you guys should know by heart. 1/5 is 0.2, 1/4 is 0.25. No 1/3 and 2/3. Those are 0.3 repeating and 0.6 repeating. 2/5 is 0.4, 1/2 is 0.5. You guys should know that. 3/5 is 0.6, and 4/5 is 0.8. These are ones that you guys should know by heart. Okay, to convert decimals to fractions, it's actually really, really simple. You say the decimal properly, no point. So think fractions and write it as exactly like you would say it. So if you want, you could even use my zero trick that I do. Place the 1 under the decimal point and a 0 under the digit to kind of tell you what it is. So, in example 6, 0.8, I'm going to place a 1 under the decimal point and a 0 over the number in case I don't remember my place value. So, this is 8/10, and I'm going to write it just as I say it, and then I'm going to simplify. I'm going to divide them both by 2 and get 4/5. And I just changed that into a fraction. So this one, in case I don't remember, a 1 underneath the decimal point, 0 underneath all my numbers, I get 5/1000ths. And I'm going to simplify. I'm going to divide them both by 5. Well, 5 divided by 5 is 1. For the bottom one, I'm going to look at 10 divided by 5 is 2, and I'm going to tag the other 2 zeros along. So 5/1000ths is the same as 1 out of 200. Okay, now this one has a mixed number. That whole number, you are just going to simply bring it as a whole number. It's going to be a mixed number. And then I'm going to do the same with my decimal part. It's 13 out of 100, and that's already in simplest form since 13 is prime. Okay. How to compare and order fractions. What do we do if we have a mix of fractions and decimals? Well, I'm going to tell you sometimes you're going to know it or see it. Sometimes it's easiest to change them all to decimals. That's personally what I like. We all know that 0.75 and 3/4 are equal, or we should, because 3/4 is one of those that you guys should know. Okay, 5/8. All right, I don't remember that one. So I'm going to change 5/8 into a decimal. Annex 0. 8 goes into 50 6 times. 48. We bring down that 2, annex the 0. I feel like we did this fraction already. 16. And then we get, yes, we did in the first slide. And then we get 40, and it's a 5. So now we're comparing 625,000 and 0.5. Now remember, if you want to, you can add zeros onto that 0.5 so that they're the same length. You have 625,000 and 500,000. This one is greater. So we eat the bigger one, we point and laugh at the smaller one. Okay, I told you the trick for anything over 9. 7 over 9 is 0.7 with bar notation, which means that it's going to be 0.7, 7, 7, 7, so on. And 70.78 is always going to be bigger. Okay, so ordering the fractions from least to greatest. Same thing. Some of the fractions I expect you guys to know by heart. Some of them you're actually going to have to do your NEATO numerator and denominator out and do the division. So 2/3, one of those that you have to remember by heart, that's 0.6 repeating. Since all my other decimals have 2 digits, I am going to add another 6 in there so that I could just compare. Okay, obviously, and remember, we're writing the original. So 0.21, that's the smallest. Next comes 2/3. And last is 0.78. And we're done. We order them from least to greatest. Now let's go to this one. Okay, these are a little bit tougher. I don't know them by heart, and they don't have common denominators, so that actually takes longer. So I'm going to change them all to decimals. 15 divided by 16. Oh boy. Okay. So I put a 0. I know it's not going to be 10. Well, it's going to be under 10, and it's very close to 160, so I'm going to tag them, try 9. Okay. 6 times 9, 54. 9 plus 5, 14. Okay. Looks like that's the closest I'm going to get. Okay. Let's see. I'm going to tag and try 4. 24. Nope, too big. Okay, I'm going to tag and do 3. 6 times 3, 18. 3, 4. Alright, I guess that's the closest I'm going to get. 3, which is 48. Now, oh, what am I doing? 10, that's a 2. And then 5, that's a 1. Okay. So, I could keep going, or I could kind of stop because I see that 9, and I see that the next decimal is 0.67. Okay, so I'm going to just wait here, and if I need to come back and finish it, that's fine. Now, 1/6. Let's see. 6 goes into 10 one time. Okay. Right away, I have a 0.1. Do I need to keep going? You can. Or you could stop because you know that this is 0.1. The next one is 0.6. And the next one is 0.9. So right away, I could kind of order them already from least to greatest. And unless you need those definite numbers, this is 0.93, dot, 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 dot. This is going to be 0.1, dot, 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 dot. Okay, so we know that 1/6 is our smallest, 0.67 is the next one, and 15/16 is the next one. Okay, now this one, 1/9. You guys should know that it's 1.11111, which is going to be our smallest one here. 0.3 is our next one, and 0.52 is our next one. Okay, remember there's a 1 here, there's a 0 there. 11, 30, and 52. Okay, actually that close is going to be for later, whole class. So, watch this video, take some notes, and then watch the other 2 videos, and then do the classwork. Check in after you finish the classwork. Okay, bye guys.